In this quick video demonstration, we're going to demonstrate subclass and superclass, as well as disjoint and overlapping using Lucid chart. So we're going to take a look at the following examples. First, we have to model animals at the zoo, so that's our superclass, that are divided into disjoint subclasses of hot-blooded and cold-blooded. And it's important that these are disjoint. Maybe the habitats are different based on whether or not they need something for being cold-blooded or not. So just like we would with a regular ER diagram, we're going to pull out an entity for animal, and then we'll populate it with an animal ID field. That's going to be our primary key. And we might have some other attributes, like maybe name of the animal, and then perhaps we have type of animal, and that's what's going to define whether or not it's hot or cold-blooded. So what we're going to do is the following. First of all, we know we're going to have entity classes for both hot-blooded and cold-blooded, and we can represent these simply like so. So we'll have hot-blooded for one entity, and then we'll have cold-blooded for the other entity. That's going to be our subclasses of the superclass animal. And so what we're going to do is actually delete these fields unless it's specified that we actually have an attribute that specifically pertains to hot-blooded. So what we're going to actually do is, because we don't have any specific attributes for hot-blooded, but we do have this subclass, we're going to go ahead and delete the attributes that are here. What we do know is that hot-blooded is going to inherit all of these attributes from the superclass animal, and we don't need to pull them into the subclass. It's going to be assumed that once we have that subclass superclass designation for disjoint, that we do inherit those attributes. So what we're going to do is just leave it like this. The only reason that this would be different is if we had a specific attribute that corresponded to hot-blooded, that was separate and different from the attributes in the animal superclass. Same thing with cold-blooded. I'm going to, since we don't have any additional attributes specified, just go ahead and delete what's in here. Now Lucid chart won't let me delete this last row. It wants me to leave it there, so I'm just going to leave it like that. And here's how we're going to do this designation. So instead of connecting like we would for a relationship, what we're going to do is represent this subclass, superclass specialization. So what I'm going to do is I'm going to pull out a circle from flowchart, and because it is disjoint, so basically if we have an entity instance that's a member of hot-blooded, it cannot also be a member of cold-blooded. It must be one or the other. I'm going to type the letter D in this circle to represent that it is disjoint. And the next thing I'm going to do is go ahead and connect the superclass to that circle. I'm going to make sure that I have that arrow highlighted and go ahead and change the end connectors to be none so that I don't have those there, and kind of adjust it a bit. And then what I'm going to do is, off of the disjoint circle, is I'm going to have arrows to the subclasses, and I'm going to click on those and change them to look a bit more like the notation in the book. So I'm going to click on them and choose this line options. So if I click on that, I'm going to choose the type that's on the far left so that it's a straight line with no angles. And then I'm also going to change the endpoint to be none. So I'm going to do that for both, and I have to make sure that I have the line highlighted before that works. Change the line option to be this first type, and then get rid of any arrow that's on there. And so this is how we're going to represent when we have different subclasses that are disjoint within a superclass. So even though we know that all of these attributes are inherited, we don't actually put them inside the subclass. And furthermore, we have just these simple line connections with the letter D to represent that they are disjoint. Now let's draw our attention to this model over here. So we have to model animals at the zoo that are divided into overlapping subclasses of aquatic and land-based. So to make this simple, what I'm going to actually do is go ahead and copy what I have and I'm going to alter it. So let's go ahead and copy that, and instead of hot-blooded and cold-blooded, we'll have aquatic as one of our subclasses and land-based. Now here, what I'm assuming is that because it's overlapping, I can have an aquatic animal that is also land-based. So maybe some kind of amphibian that needs both water and some kind of land. So it's not going to be completely submerged like a fish, but it needs both maybe types of habitats. So that's a consideration that we have to make. So in order to represent this, I would use the same representation, but in the circle, instead of the letter D, I'm going to have the letter O to represent that it's overlapping. So again, this is to represent where we can have members of a subclass that are members of more than one subclass of a superclass. So I could be both aquatic and land-based, as opposed to if it were disjoint, where I use the letter D and that the subclasses are disjoint. So hopefully this helps you see the modeling process for subclass and superclass. Of course, we can start to build that tree structure that was mentioned in the conceptual video, in terms of we can have additional subclasses built off of these subclasses. And we can also have relationships that connect either from a superclass or from a subclass. So we can have basically any of the things that we've seen so far in ER modeling, but extend those to this subclass and superclass model. If you have questions about this, please let me know.